Jahnavi from BTech second year of ECE branch. I am discussing about the subject of signals and systems. In signals and systems, I have to discuss about the operations on signals. In this operations on signals, we have amplitude scaling, addition of signals, multiplication of signals, time reversal and time scaling, time shifting. Those are the types of operations on signals. First, we have to see about amplitude scaling. The definition of amplitude scaling is amplitude scaling, the scale signal x of t multiplied by a factor where a is constant real number, such as the physical device that performs amplitude scaling is an electronic amplifier, means x of t time is multiplied with constant. This is the example of amplitude scaling. This is the amplitude and this is the time period. Here time period is -2 to +2 and amplitude is 1. This is also example of amplitude scaling. This is the amplitude and this is the time period. Here the amplitude is 2. Amplitude is 2. Time period is -2 to 2. Amplitude scaling. Simply amplitude scaling means amplitude is changes with respect to time. Next, addition of signals. Addition of signals. X of t and x2 of t denoted as a pair of CTs control systems. The signal z of t obtained by the addition of x1 and x2 is defined as zt equal to x1 of t plus x2 of t means x1 is added with x2 and x1 plus x2 equal to z of t. In this case of DTS, it written as Zn equal to x1 of n plus x2 of n. This is for discrete signal. It can be noted that the addition of two signals is nothing but addition of their corresponding amplitudes, explained by using the following example. Addition of two signals means add the two signals amplitude is called addition of signals. First signal is x1 of t and x2 of t. Add x1 of t with x2 of t and we get x of t. In continuous signals, x1 of z n and x2 of n added and we get z of n. This is for discrete signals. Next example of addition of signals. Here the amplitude is 1, time period is -3 to 3. Here this is x1 and this is x2. Here the amplitude is 2, time period is -10 to 10, and this is the z of t. When we are adding this both, we get x1 and x2, we get zt, and here x1 of t -3 to 3 and x2 of t -10. These both are added and we get addition of two signals z of v and we get z of t. Subtraction of signals. Definition. x1 of t and x2 of t for two pair of control systems, then the signal z of t obtained by the subtracting of x1 of t from x2 of t is defined by z of t equal to x1 of t minus x2 of t. In the case of DTS, it written as DTS means discrete time system. Zn equal to x1 of n minus x2 of n. This is similar to addition operation, but in addition operation we are adding the amplitudes of two signals. In subtraction we have to subtract the amplitude of signals from x1 of t subtracted from x2 of t, and we get z of t. This is for continuous, and for discrete, z of t equal to x1 of t minus x1 of n minus x2 of n, and we get z of n. This is for discrete. And next example of subtraction of signals. This is the example of subtraction of signals. This is the amplitude of the signals x1 of t minus 1 to 1. This is the time period of the signal 0 to 6, and we get x1 of t. We take as sine of t. This is x2 of t, and the time period from minus 5 to minus 0.5 to 0.5, and this is the time period 0 to 6, and we take it as 0.5 cos of t x2 of t, and we add this x1 of t sin t, and we subtract this x1 of t and x2 of t sin t minus 0.5 cos of t, and we get the signal like this: y of t equal to x1 of t minus x2 of t. And we go to next signal, multiplication. Definition of multiplication of signals. Let x1 of t and x2 of t denote as the signal z of t resulting from x1 of t, and is defined as the following: z1 of t equal to x1 of t multiplication x2 of t, z1 of t into x2 of t. We multiply this x1 of t with x2 of t, we get z of t. This is for continuous. Z of n equal to x1 of n into x2 of n. We get z of n. This is for discrete. And you see the example of quantification of the signal. Here, this is the amplitude minus 1 to 1. This is the time period 0 to 0, 1, 2, 3, 4, 5 to 6. This is the signal x1 of t sin t, and here x2 of t. Here the amplitude is minus 1 to 1, and the time period is 0 to 6. This is the signal x2 of t cos of t, and we multiply this x1 of t with x2 of t, we get y of t as a signal. This is the signal for multiplication of signals. Next, we have to see time scaling of a signal. Time scaling is the compression or expansion of a signal x of t. Z of t is independent variables. Time of t by a factor a is defined by two cases. If a greater than 1, the signal z of t is compression of x of t. In case z of t equal to x of at. If a less than 1, the signal z of t computed as z of t equal to x of t by a. The factor a must not be equal to 0. In the time scaling, if a greater than 1, the signal is compressed version. If a less than 1, the signal is expanded version of x of t. This is the definition of time scale. And this is the example of time scaling. Here the amplitude is -1 to 1. And the time period is -4 to +4. This is the signal x of t. It's x1 of t sin t. X of t sin t. And this is the time compression of the signal -1 to 1. And the time period is -4 to 4. And this is the time expansion of the signal. Amplitude is -1 to 1. And the time period is -4 to 4. Simply time scaling means if a less than 1, time compression. If a greater than 1, time expansion is possible. Next, time shifting of signals. Definition of time shifting. X of t defined a new signal by adding or subtracting a finite time value from it. Z of graphically, this kind of signal operation represents in a positive or negative shift of the signal along its time axis. Change of just positioning of the signal without affecting its amplitude. Time shifting means signal x of t amplitude is changing without affecting its amplitude. Waveform is changing without affecting its amplitude. If it is x of t, then z of t equal to x of t minus t. Is the signal x of t shifted to the right by t units? If the controls continuous time system is x of t, then x z of t equal to x of t plus t. Is the signal x of n shifted by the right by n samples? Next we have to see example. This is x of t sin t. We take the signal and we get x of t minus 2 means delayed by 2. X of t plus 2 means advanced by 2. This is about time shifting. Simply time shifting means the signal is changes with respect to time without change in its amplitude. We have to see time reversal. The z of t represents a reflected. X of t denotes as y of t equal to x of minus t. This is for continuous. Y of n equal to x of minus. This is for discrete. Next we have to see a definition of time reversal. This is the time reversal. When y equal to -1 is the case of folding of a signal along y-axis. This is the amplitude and this is the time period -1 to 4. And this is also 1 to 4 time period. This is time reversal. Means that with respect to time, the position of the signal changes. This is about the operations on signals. And thank you.